Okay, so now we are going to do some more examples of what we learned in the last video, which was all things based on sine, cosine, and tangent ratios when we're dealing with right triangles. So if we take a look at this example here, let's draw a triangle. And we'll go ahead and mark this so that we know it is a right triangle. And we'll label this, I don't know, let's go with pig. I like picking animal names. So we'll label this pig, and I'm going to tell you that this angle here is x, and this angle here is 12. And then I'm going to tell you, I'm sorry, not angle. This side is x, this side is 12. So then this angle in here is going to be 32 degrees. So if we're looking at this example, we are given angle I, so we're going to look at angle I. So in relation to I, x is adjacent and 12 is opposite. So again, write up your SOHCAHTOA up at the top. SOHCAHTOA. And we're looking for a ratio that has an O and an A in it. Once again, the only one that has O and A is TOA, so we're going to use tangent. So we have the tangent of I is equal to opposite over adjacent. The tangent of I, and I is 32, so we can plug 32 in there, is equal to opposite, which is 12, over adjacent, which is x. So now from here we just need to solve for x. To do that we can multiply both sides by x to get x out of the denominator. So we're left with x times the tangent of 32 equals 12. And now don't let that tangent of 32 scare you. It's still a number, so we can just divide both sides by the tangent of 32 to get x alone. It's going to cancel out here, so we're left with x is equal to 12 divided by the tangent of 32. When you plug that into your calculator, you should get about 19.20. So that means that this side here is 19.20 approximately. So hopefully that makes sense. Let's do a few more examples. The next one, we'll go ahead and draw a triangle. We'll tell you that it's a 90-degree angle, and we'll label this one, let's just pick random letters, M, N, and P. Okay, so I'm going to tell you that this side is x, this side is 50, and this angle is 21. Okay, so we are going to look for SOHCAHTOA, and we're going to figure out how these sides relate to P. So we're looking for angle P. In relation to angle P, this 50, it's a 5, is the hypotenuse. Do not get tricked into thinking it's adjacent. Remember in the last video we said that the hypotenuse is always considered the hypotenuse. And then x would be opposite, so we're looking for an O and a H. The only one that we can use is sine. So we're going to write the sine of 21. I'm sorry, let's write it with just our formula first. So we have the sine of P is equal to opposite over hypotenuse. So now we can fill in the numbers. So sine of P is 21, is equal to the opposite, so that's x, over the hypotenuse, which is 50. From there we just solve for x. So multiply both sides by 50. These two cancel out. We're left with 50 times the sine of 21 equals x. You just plug that into your graphing calculator, and you should get x is equal to 17.92. Now a really fun trick is that you don't have to use only the information that's given. So I'm going to erase all of this and put back up what I had. So I had that this was M and P. This is a 90-degree angle. This is x. This is 50, and this is 21 degrees. So if you really, for some reason, hate sine, you have a big beef against sine, you can just solve for angle n and then use some other trigonomic function. So we know that the internal angles have to add to 180, and we already know that m is 90 degrees. So we only have 90 degrees left over. Well, now we know that p is 21, so we know that n has to be 69 degrees. So n is 69 degrees. So now, using n, the value of n, we can solve using something else. So let's look at n. And in relation to n, x is adjacent, and 50 is the hypotenuse. So we're looking for an a and an h. Now we can use cosine instead of sine. I'm going to switch colors because that's hard to see. But now we can switch to cosine. So let's go ahead and solve. So the cosine of n is equal to adjacent over hypotenuse. The cosine of 69 is equal to adjacent, which is x, over 50. Again, we're just going to solve for x. So multiply by 50 on either side. So we have 50 times the cosine of 69 equals x. And you should get x is equal to 17.92. If you notice, that's the exact same value that we got last time when we used it with sine. And that's because if this side length is 17.92, it will be 17.92 no matter how you solve for it. So this is a great way of checking yourself when you're doing your homework or on a quiz, is by solving for it multiple ways. That way you make sure that you're getting the right answer both times. Okay, we'll do one more problem that's from your homework. So let's set this up, and we'll put our little right angle in there. So now with this one, this is x, and our hypotenuse is 17. Oops. Hypotenuse is 17, and this angle down here is 59 degrees. All right, so we're going to use 59 degrees. I guess we should label our triangle. We'll label it ABC. Really original. So if we're using the angle 59, 17 would be the hypotenuse, x would be opposite. So which which function has an O and an H? That would be so. So we're going to use sine. So the sine of C is equal to opposite over hypotenuse. The sine of 59 is equal to x over 17. X over x, oh my goodness, by multiplying both sides by 17. So you're left with x is equal to 17 times the sine of 59. And you should get, let me see here, times 17 is equal to, come on, oh my goodness, 14. Whoops. You should get 14.57. X is equal to 14.57. Just ignore all that, I'm sorry. So x is equal to 14.57. So hopefully that helps clear up any questions that you might have. If you still have questions, you can always email me or post a comment on here. So thank you very much and have a great night.